Question 5. So for part A, find the exact value of P. So we know this coordinate here lies on the curve, so we just need to substitute in the y value into this curve and out will pop P. So P equals the curve with pi over 2 substituted in. So substituting pi over 2 in, we get this inside the bracket. Sine pi is 0, so we've got P equaling 2 pi all squared, which is 4 pi squared. Now for part B, we're going to want to start off by finding the equation of the tangent of the curve. So we're going to need to know two things. We're going to need to know the gradient of the tangent, and secondly we need to know a point on the tangent, which we know already. So let's work out the gradient of the tangent, and to do that we need to differentiate the curve. So we need to differentiate this. So dx dy, following the chain rule, dx dy equals the bracket multiplied by the current power and reduce the power by 1, so the 2's become 1 effectively, and then you multiply by the differential of the bracket, which is this. So then substituting in at our point P, when we know y is pi over 2, we get dx dy being this. Working that through, we get dx dy to be 24 pi, and so then just finding the reciprocal of this, dy dx equals 1 over 24 pi. So we know the gradient of the tangent, we know a point on the curve, which is P pi over 2, in other words 4 pi squared over pi over 2. So substituting that into the equation of a straight line, y minus y1 equals mx minus x1, and we know our point, we know our gradient, we get this. So just rearranging this a little, we get this being our equation of the tangent. Now we're being asked to work out where the tangent cuts the y-axis. Well, it cuts the y-axis where x equals 0. So substitute x being 0 into this, we get y equaling this, and then tidying that up we get y coordinate being pi over 3, so the coordinate of A is 0 pi over 3.